Hello, everyone, and welcome to another episode of the podcast titled When Wildfire Comes. My name is Dr. Christopher Potter, and I'm a wildfire scientist with over 30 years of experience working for NASA, our nation's space agency in California, and working with local communities impacted by weather and wildfires and wildland fires as they burn close to our populated areas all throughout the state and the West. I've studied wildfire and the urban interface using satellite imagery and ground measurements for most of my career, and studied all the most destructive fires in the Western United States, publishing dozens of papers in science journals on these events. And I myself live in a high risk wildfire zone in Northern California. So I have had some firsthand experience with the topic. So today we're going to hear from our invited guest about their knowledge and their experience in dealing with fire weather. So slight departure from what we normally talk about, which is a specific fire. In this case, we're going to be talking about a lot of different incidents and fires that have occurred over the past several years and what's behind them in large part, the weather that makes it not just a regular fire, but a firestorm or a complex fire where fires join one another and spread into urban areas driven by wind, high winds. This is not a breaking news report on any of those fires. It's a scientific study today, during which our guests will tell us about their experience in forecasting these fires and the actual incidents, and how their job gets more intense during these wildfire events. So today I'm very pleased, and I think you're going to really be educated by Matthew Mehle, who is the lead meteorologist for the San Francisco Bay Area Weather Forecast Office. He's based in Monterey, California, which is on the central coast of California, but he covers all of Northern California and the Bay Area in terms of weather forecasts. So, Matthew, thank you very much for joining us today. Would you just like to tell us a little bit about how you came to work for NOAA, and then what your job is like on a day-to-day basis, both during the non-fire season and during some incidents? So welcome, Matthew.
Yeah, thanks for having me. Yeah, so I started my weather service career in Goodland, Kansas, and that was in 2004. And I saw a wide variety of weather there: tornadoes, severe thunderstorms, a bunch of different really impactful weather. And then I got a promotion and moved west to California. When I moved to California, I learned about something called fire weather. That was all new to me. We don't have a lot of tornadoes or severe thunderstorms in the West, but the one thing we do have is fire weather. And that's basically our severe weather. So that's kind of how I got started. As you mentioned, I am working for the National Weather Service for the Bay Area. We cover the Bay Area and part of the Central Coast. And since I've been here and became more interested in fire weather, I also learned about a program called Incident Meteorologist. That's a specially trained meteorologist that can get deployed to incidents around the country. And here in California, the West, those incidents would be wildfires. So my day-to-day job is in the Weather Service office here in Monterey, but during fire season, which is pretty much all year now, I get deployed to wildfires. I provide weather information to the incident management teams. The main reason I'm there is to make sure that the firefighters are safe, personnel on the ground are safe. Weather is a major factor when it comes to fires. And then the other reason I'm there is to help the team with their strategy and how they're going to attack and kind of put out the fire, or manage the fire so the surrounding communities and the forest itself can recover.
Yeah, so this involves a collaboration between you at a federal agency down to Cal Fire at the state agency, and then even local county and local city firefighters
That's
during an incident.
Yeah, that's correct. So I get ordered up under the incident command structure, so I fall in place with that group. And those groups vary, as you mentioned. It could be a federal team, it could be a state team. I've worked with Cal Fire, I've worked with the Oregon I've worked with Utah, Nevada. I am located in Monterey, but I'm considered a national resource. So I do travel around the country, and that is very common for incident meteorologists. They get deployed anywhere there's a call or need, and we'll show up and support fed, state, or even local.
Yeah. So you have the advantage of having, let's say, the big picture view of what's going on, right? You're looking at satellite data a lot during the incident.
We are. So that's one of the key tools that we use, especially once we upgraded our satellites within the last about 7 to 10 years when we changed from our old GOES to our newer GOES. The easiest way to think about that is when we did that upgrade, we basically went from a tube television to a 4K flat panel TV as far as
That's a great
quality
way.
goes.
It's a great way to
It's
talk about it.
it's it is amazing what we can see. We can get 1 minute satellite imagery over top of a wildfire. And it is really good for meteorologists to monitor that from
Hmm.
a safety standpoint. As I mentioned, that's one of the main reasons I'm there. Firefighters on the ground, they're not always looking up. They're not checking out the top of the clouds. They're not paying attention to all that all the time. So they can have somebody like me there that will monitor that via
Yeah.
satellite, and I can see that there's a pyro queue or a towering cloud or a developing thunderstorm, and that's going to impact the firefighters. And I can do an update on command or the radio to let personnel know that, hey, conditions are changing. You know what to do because you've been trained for this, but heads up, we've got pyro queue that could create lightning, could create gusty winds, or it could even collapse. So those are all
Yeah.
hazards that firefighters have to watch for.
Yeah. And just briefly, GOES is a geostationary satellite, right? It's always looking at the
Yep,
same place.
that's correct. So we have two main ones that cover the United States. We've got Goes East and Goes West. Goes West is centered over parts of the Pacific, but it does cover the entire West Coast. And as I mentioned before, the incident meteorologist can actually call headquarters and ask for a what they call a mesosector. So we basically get a postage stamp size, kind of zoomed in area over our incident, which is super helpful.
Yeah, that is super. And you said the repeat frequency is every minute that
It
takes an
is,
image?
yes. Yep, the standard imagery is about 5 to 10 minutes, but if we go into mesosector where we're requesting that zoomed in, that comes in every minute. And that's when you animate that on our computers and we can watch it in real time. It's really impressive. You could see a fire make a run up a slope. You can see the resulting column that would develop. There's a lot of really great information that we can obtain from satellite imagery.
Yeah. And what is the detail level? I mean, can you see a city block as your
Um,
resolution?
Yeah, off the top of my head, I can't remember the exact resolution, but it's pretty close. We can pick up fires that are, within like tens of acres when it comes to heat signatures.
Hmm.
It's really impressive. Whereas before we used to have about an 80 to 100 acre fire. Now we can pick up much smaller heat signatures.
Oh, so the imagery does have the infrared capability, or do you need to
Correct.
combine it with other satellites to
Yep.
do that?
Yep. So we were able to use all parts of the spectrum there to analyze the imagery.
Hmm.
We'll kind of piece it together to get visible imagery of what it would look like if we were standing in outer space looking at the globe. We're able to put together different bands to give us curated heat signatures so we could tell how much output the fire is generating, and then we were able to use some correlation on that heat output as to far as like the severity or what's actually happening with inside the fire.
Uh-huh. Excellent. Well, that's amazing. The federal government has invested um, so much, so many resources, expertise, funding these satellites, keeping them going over the years. They've become indispensable, haven't they, to really effectively fight a fire like this, any big
Oh, for
fire.
sure. Yeah, it's not just fires, it's weather in general.
Yeah.
Right now parts of the country are being impacted by atmospheric rivers and that's dumping tremendous amounts of rain, and satellites are definitely being used to kind of curtail, show where those moisture plumes are. We get them here in California too, the Pineapple Express. When
Hmm.
those like, take aim at the coast, we're using satellite imagery to track where that moisture plume is, and it's super impactful. So yeah,
Yeah.
satellites
Yeah.
are indispensable to us meteorologists.
Yeah. And then after a fire, of course, the area is can be much more unstable on the coast. And so you're looking for the impacts, the compounding impacts of landslides, rock slides, erosion, things like that, right?
Yep, that's correct. So after a fire, we transition to, kind of the rehab repair part, but also first responder part of it would be debris flows. We had the
yeah.
Montecito in Southern California a few years ago. We've had minor slides and debris flows in the Bay Area post wildfire, but we're able to use satellite imagery, different satellites, not GOES per se, but different satellites that measure vegetation type, and you can kind of get a rough guess of burn severity. So
Hmm.
areas that we would need to focus on of, oh, this hill slope basically got slicked off or really had a severe burn. So that area is going to be highly susceptible to debris flow versus this slope that maybe had moderate fire behavior and didn't burn off as much. But yeah, having satellite imagery to kind of use for post wildfire analysis is also a key part too.
Yeah. Since you mentioned it, let's just briefly talk a little bit about the Montecito incident when a fire occurred just outside of Santa Barbara, right in the hills, in the mountains above Santa Barbara. And then after that, when the rains came, a gigantic mudslide buried neighborhoods in the posh city of Montecito, isn't that right? And so I guess the lesson is that once the fire is over, the disaster is not necessarily over.
Correct. Yeah, we deal with that. So federally and state, they have post wildfire analysis teams. So for federal, it's called BEAR, so that's Burn Area Response. And basically, we have hydrologists and other people that have specialties with USGS, and they'll go out and analyze the soil. They'll see how hydrophobic, or basically how receptible it is to receiving or not receiving rainfall. And that will kind of give us meteorologists like a heads up, hey, this area has a high potential. The
Yeah.
state also has a program too through CAL FIRE in the state. They're called a WERT, WERT, so that's Watershed Emergency Response Team. They do the same type of thing, and they work with state and federal partners, and will kind of do that post wildfire analysis to gauge what would happen if we got a lot of rain or a thunderstorm
Hmm.
or something over it. A lot of the times when it comes to post wildfire analysis and debris flows, it's not the amount of rain, it's the intensity of the rain that tends to be one of the key thresholds. And it's those short burst heavy showers
Hmm.
of 15 minutes or less. That's just a lot of rain. The soil can't take it. It's hydrophobic. So basically you slick off the top, and then it's just compounding dirt and debris that gets pushed down the
Yeah.
hillside.
Yeah. Yeah. It can take years to recover, for an urban area to recover from all that debris flow into their
Yes.
areas, and it brings with it all kinds of um, hazardous things coming down with it, right? Large pieces of forest
Yep.
material, and maybe even pieces of houses that are up slope
Yeah,
from it.
and exactly that's the key there. It's the difference between a mud flow and a debris flow. The debris, you're pulling all kinds of stuff down the hillside. It could be large trees, boulders the size of small cars. I mean, it's impressive the sheer volume of material that can come down a hillside when you actually have a debris flow.
Yeah, yeah, it's amazing. Wow. So, well, today I really wanted to sort of shift the gears a little bit because I know that when the wildfires are being driven into the urban wildland interface, it at that point the fire started. It's usually very dry. It can be very dry. Doesn't have to be, but it could be. And we get what are called Diablo winds in Northern California. And if you could tell us what are Diablo winds in a layman's terms, and maybe how they differ from what most people in Southern California are very familiar with, grew up with Santa Ana winds. So from basically the direction and intensity and origin, how do those two events sort of contrast one another?
Sure. So let me give you a little meteorology 101.
Yeah, great.
In addition to going to wildfires, I actually teach fire weather classes for firefighters. As you can imagine, firefighters have to be aware of the weather and the surroundings. It's part of the fire weather. It's part of the fire triangle. Weather is a key piece. So part of the teaching process for firefighters is we discuss a variety of impacts, including these winds. So when we talk about the winds, we're basically talking about what's called a foehn wind. And a foehn wind is nothing more than a fancy term for wind that's being pushed down a hillside. And the characteristics with foehn winds is basically they tend to be warmer, they tend to be drier, and they'll be much stronger when it comes to the actual wind speed itself. So relating it to the Diablo wind, it's a variety of foehn wind. We have foehn winds all across the country. They all have local names. Diablo is what we call them. Santa Ana winds is what Southern California calls. If you're in parts of the Central Coast, they'll call them sundowners. If you're over in the Rockies, they'll call them the Chinook. They are all basically the same thing. They're wind coming down a hillside. And what happens meteorologically, if you were to take, let's call it a parcel of air, and think of it as like a cube or a sphere. Let's put it up on top of a hill. So in the Bay Area, let's say we put it up on Mount Diablo. We push
Yeah.
it down the hillside. That cube or sphere is going to get smaller, and as it gets smaller, it's going to heat up. And when it heats up, it's also going to dry out. So that's going to be our hot, dry scenario. And then since it's being pushed down the hillside, we're dealing with the winds. So now we've got the trifecta: hot, dry, and windy. That's not what you want to have when you're talking about fire weather conditions being great. It's not.
Yeah, it's the
You're going to
perfect
have
storm, right?
exactly. Yep. So the Diablo versus the Santa Ana holistically aren't drastically different at its core. It's just how they form is slightly different. So in Northern California, for us to get the Diablo winds, we have areas of high pressure that build across the Great Basin, and we have low pressure along our coastline. So that pressure gradient between the two, the pressure from the high to the low, is what really drives our Diablo winds. In Southern California, for your Santa Ana winds, you've got high pressure sitting up over the high desert with low pressure off the San Gabriels or the Angeles, and it's basically to the west off the coast. And that kind of sets the storm setup for offshore flow. So at its core, they're basically the same thing. They're just located in two different parts of the state.
Yeah. Okay. Great. So that's really helpful. So why don't we talk a little bit about uh, some of the fires you've worked on as an incident meteorologist that you feel were really changed by in Northern California by the intensity of the wind event. Where would you like to start? What's a good fire to
Yeah.
start with?
So I think probably one of the most noteworthy ones is let's go back to 2017. So leading up to 2017, we had 5 years of record-breaking drought. We had stressed trees, both morbidity and mortality across Northern California. And then fast forward just a few months, we had the 2016, 2017 winter. We had solid rainfall. So that led to rapid growth of finer fuels. So we basically were setting the stage. The big fuels, so that would be like your trees, maybe even some of the brushes, but the finer fuels, your grasses, grew rapidly. So leading up to the fall of 2017, the stage was set. We were dealing with a long period of drought, but we had a lot of fine grass and fuels. Then factor in the weather. We basically set the stage to have a red flag warning. So that's the National Weather Service sending out an alert saying, hey, weather conditions and fuel conditions are at its peak, and we are really concerned that we're going to have a fire. And we set up with offshore flow. We got those Diablo winds, high pressure built across the Great Basin, and low pressure was along the coast. And then we really started to crank those winds out of the Northeast. And as a result, we ended up with the Tubbs Fire. The Tubbs Fire is probably one of the most noteworthy ones out of a complex of fires that developed across the North Bay in 2017. But the Tubbs Fire is one that I was actually called and deployed to. I can clearly remember it, leaving Monterey, and I could see haze in the sky, but man, when I got up to Berkeley and Oakland, there was smoke. And that was a
Wow,
little unusual.
already
It
down
was,
that far.
yeah, it was unusual. And most of the fire growth with the Tubbs Fire occurred in that first 8 to 12 hours. And
Fast,
it was
fast.
all it was driven by the winds. We had some unprecedented winds that set up across the North Bay with that kind of offshore flow, and those winds kind of screaming down off Mount St. Helena and the higher terrain up by the geysers, and yeah, it was crazy the amount of wind that we had. The Mayakama Mountains kind of also helped accelerate some of those winds kind of coming down. And probably one
Yeah.
of the thing that sticks out in my career with that fire is, yeah, meteorologically it was unprecedented to see some of the stuff that was being observed, but I went out and did a damage survey in an area called Coffee Park. And the Coffee Park is a small community just north of Santa Rosa, and I went there and it was just a moonscape. The structures were gone.
Wow.
You saw chimneys, but I saw cars wrapped around poles. I saw cars wrapped around trees. So I put on my scientist hat and I was like, what actually happened here? Was this a pyrogenetic tornado, or was it just really strong winds? And through some analysis and some research that was done by San Jose State University, it turns out it's something called a hydraulic drum. So let me break that down simply here. So when
Can
we
you
have
say it
those
again?
Diablo,
Hydraulic
it's
drum?
yeah, it's hydraulic jump,
Oh, jump. I
JUMP.
got
Yep.
it.
So it's a term used in physics, and in this case, when we have those offshore winds or those Diablo winds, they go across mountaintops, and when they go across mountaintops, they create a wave pattern, and sometimes those waves in the atmosphere, because it's a fluid, will break, and when they break, they surface, and that's what happened with Coffee Park. So not only did we have the strong offshore flow at its heart, driving much of the weather across the North Bay during that period. But then we had a localized burst of heavy wind and strong wind that screamed through Coffee Park. And that's
Hmm.
actually when the fire was coming down the hillside. And the rate of spread with that thing was really, really fast. Some of the fastest I've ever seen in my career. And it just blasted through Coffee Park. At that
Yeah.
point, it was protecting lives, trying to evacuate as many people as possible, and that's what the first responders were doing during that time frame. But it was all driven by that breaking wave off the high terrain that surfaced and went through Coffee Park. So
Yeah. So,
that one
so
definitely sticks out there as one of the more noteworthy meteorological scenarios when it comes to Diablo winds in the Bay Area.
yeah, for sure. So conceivably, had there not been a fire that started up near Calistoga and got swept up into those winds and embers being transported very rapidly, firebrands as they're called, right? Large pieces
Yep.
of burning wood in the wind, transported all the way like 10 miles down into the Santa Rosa area. Had there not been a fire source anyway, that event, that hydraulic jump, do you think it would have damaged the neighborhood anyway?
Oh, for sure. So when I was up in Healdsburg, part of doing the damage survey, we were driving around the North Bay Mountains, and I saw live coastal oaks with, branches that were easily 6 to 12 inches across, just snapped in half. So
Hmm.
outside of the fire itself, there was clear damage. In addition to that, there's a ranch up there off of Hawkeye, and that's up above Healdsburg. And I went and did a damage survey on this gentleman's property, and he had a barn that had part of the roof peeled off. So, like you said, no fire, we would not have had a devastation, but we still would have had damage because the winds were so strong with that jump as it surfaced, that breaking wave. The winds just howled through that area and caused damage, regardless of fire on the ground or not.
Yeah, I know I've seen reports that the winds around Santa Rosa were recorded at upwards of 70 miles an hour, right? And
Yes,
gusts of 70 miles an hour. And it's more or less like this is Northern California's version of a hurricane.
exactly. Yeah, when you put it that way, it is. We actually had winds over 100 miles an hour recorded up in the higher mountains during that time frame. Let's see here. I'd have a site off of Geyser Peak that was 103 miles an hour during that event.
Wow,
Just to put it in
that's like a
perspective. That's
category 4 hurricane on the coast, on the
Yep.
Gulf Coast, or Atlantic coast. And so we we got it all here. We've got hurricanes occurring but coming from a source that is not tropical, right? It's not a tropical. It's an extra tropical, not even extra tropical, I guess you'd say, because an extra tropical storm is one that starts in the tropics and moves into the non-tropical areas, right?
Yep, yeah, and I won't even call this a storm per se in the normal perspective of like having precipitation with it. We didn't have any. It was
Right.
just it was this was all pressure gradient driven, high pressure and low pressure, and the difference in between, and that's what we ended up was
Yeah.
strong, dry offshore flow.
And so what changed in the larger atmosphere in the Pacific Northwest to make this more or less an unprecedented event?
Yes, so the in the big picture, obviously we focus on the Bay Area, but if we're looking at the West, which we have to, you have to look at the bigger picture. Um, so we get these little systems that roll through the Pacific Northwest. Could be what we would refer to as a shortwave trough or a small area of low pressure. Typically, what happens is those will go through the Pacific Northwest and then exit through the Great Basin. As that system exits, what's quickly to build behind it is an area of high pressure. And
Hmm.
that's how we kind of set the stage. And that's kind of what happened there in this event. We had a little system go through. We had high pressure build across the Pacific Northwest, nosed into the Great Basin, and then it kind of sets the stage. Then we have to see what is the pressure level along the California coast. And in this case, it was low along the coast and very high across the interior, and that set that offshore pressure gradient.
Yeah. And and what part of the atmosphere is this happening in? Is it relatively close to the ground, or is it like a mile up or
So we have a few different scenarios that we focus on. Generally speaking, the main driver is going to be at the surface,
hmm
but then we refer to something called upper level support. So the high pressure that I was mentioning, building across the Great Basin, that's going to be at the surface, and a low pressure is going to be at the surface too, but along the coast. So now, if we go up to about 20,000 feet, and we're looking at what's the upper level atmosphere doing, where it becomes problematic, and this is what happened in 2017, is if we also get high pressure to build across the Pacific Northwest and kind of assist the surface high pressure. So high pressure, if you were to look at it on a map, the flow around high pressure is going to be clockwise.
hmm
And in this case, the way that the upper level support or upper level high pressure was setting up, that clockwise flow was basically northeast to southwest across California. So that was in the same direction that we were seeing at the surface. So not only were we offshore at the surface, we were offshore all the way up to about 20,000 feet. And that allowed for enhanced offshore flow. That's the key setup that we look for as meteorologists. What's happening at the surface and what's the upper level pattern look like too?
Right. Yeah. Well, that's no, that's a great explanation. Um, so what about you want to talk about maybe another fire that might have been a little different than Tubbs, but you feel like was really driven to being a disaster, a bigger disaster than it might have been had the winds not done their part.
Yeah, so another one will be up in the North Bay. This one, fast forward 2 years later, this is called the Kincaid Fire.
Hmm.
Similar time frame, October. That is our peak fire season in the Bay Area. That's also tends to be the peak season for Diablo or offshore winds. So that one was also an offshore event. We had really strong winds, but this is the slight difference with this one outside of the meteorology was what I want to refer to as community resilience. There was a lot of lessons learned in 2017, and as a result of that, Sonoma, Napa, first responders, county, and state officials, had a better playbook when it came to 2019. And as a result, based on the weather forecast that we were putting out, one of my colleagues was the incident meteorologist deployed on the wildfire up there. And based off of what we were seeing and the weather that was anticipated, they did more large scale evacuations ahead of the time, which was fantastic news. Because as a result of that, the first responders weren't trying to evacuate people as the fire was unfolding. They were able to fight the fire. Whereas in
Yeah, that's
2017,
important.
it was so quick, they weren't fighting fire at that point. It was let's try to save lives and get people out of there. So community resilience played a bigger part and lessons learned played a bigger part in 2019. And I think more people's lives were saved as a result of that.
Yeah, the tragic difference is that um, tens of people died in the Tubbs fire, right?
Yes.
And
Yep.
I can't remember how many died, if any died in the Kincaid fire, but you're saying much less.
Yeah, that's correct. Yep.
Yeah, yeah, that's amazing. When you now you have the ability to give some advance warning to everyone, and if they're, I don't know if sirens have to go off, but at least text messages start going out to people, right?
Yeah, and that's one of the lessons learned. In 2017, I don't remember off the top of my head how much information went out. I know a civil emergency messages did eventually go out, but in 2019, they were issuing all kinds of alerts because people were ready for it. They signed up to get text messages through Nixle and the county alert systems that they have up there. And if I remember correctly, it was one of the largest evacuations that they had in Sonoma County history. Just shy of
Mhm.
about 200,000 people were evacuated ahead of time because of the impending weather and the forecasts and the intel that they were getting from people on the ground.
Yeah. Hey, do you recall during that incident whether any there were any constraints on from so the winds then how high did they get?
About the same. They were about 100 miles an hour up in the hills.
Wow.
There was a site up in the Healdsburg area that clocked about 103 miles an hour. So just a little bit shy of what we saw with the Tubbs, but still noteworthy nonetheless. But like I said, having that, incident meteorologist on site conveying the weather threat to the sheriff, to CAL FIRE, to the local officials, they were able to act and respond and evacuate people before anything really got out of control.
Yeah. So in contrast again, Tubbs fire, wind comes up, reaches 70 to 100 miles an hour throughout the corridor where the fire is going to be spread down into the lower urbanized areas, and then it's over. The wind's over in 24 hours, right? It's died down. And
Exactly. Yep.
was it the same during Kincaid?
Yeah, so the way it works with the Diablo winds, it's rare that we have long duration events. Generally speaking, Diablo events in the Bay Area can last maybe 2 to 3 days at most, but they subside there during the day, which might seem a little bit counterintuitive, but they tend to be the strongest very late at night and just shortly after sunrise. And
Hmm.
that's because we have inversions or basically different levels of the atmosphere that are a little bit more stable that allow the winds to kind of accelerate. But during the day, we get a little bit more mixing once the sun comes up. So some of that stuff kind of fades. But fortunately, we don't have 5 to 7 day offshore flow events that are going to be catastrophic from 100-mile-an-hour winds.
Yeah, but still, do you recall whether there were any constraints on air, resources being able to fly and during the Kincaid fire?
Yeah, so I don't know off the top of my head, but I know just from general experience when I'm deployed to wildfires, in addition to giving weather reports to the firefighters and the team itself, I definitely provide information to the aviation assets that are working on fires. They all have different criteria, whether it's a fixed wing or rotor, so that's helicopter or airplane. They all have different requirements on what type of aircraft they're flying. And as I mentioned before, these Diablo winds create these wave patterns and breaking waves. It goes without saying that obviously that would impact aviation. Once the winds are strong enough, they're not flying. It's not safe, so they're not going to be up in the sky for that stuff.
They have to wait till those winds subside, and then
Exactly.
they can get the tankers back, back
Yep.
in running order and be safe. Yeah, I could imagine trying to fly through some sort of atmospheric turbulence like that. It would be a horrifying and very dangerous experience for any pilot to try that, and it's not worth it. Um, so, well, that's a great contrast, between a couple different fires like this. So I got to ask, the big future question, and that is there any evidence that the frequency, let's say the frequency of diurnal wind events like this that can reach up to 100 miles an hour in the upper elevations is related to climate change?
Yeah, so that is the million-dollar question. I in my office I focus on near-term forecasting. So I'm by no means am I a climate scientist, but that's where I have to rely on my counterparts that are in the research world. And one of the great things about the Bay Area is we have a fantastic local university, San Jose State University, and they do actually have a fire weather track, one of the only ones in the country, and they do a lot of great research. And based off of some of the findings and the research papers that they've put together, um, they're not finding any correlation in the future to showing that we're going to have more intense wind events or a higher number of Diablo events across the Bay Area. There's no statistically significant trend in that regard. The one thing that is clear in some of the research in the papers is the concern will be the dryness, or basically the other part of our fire weather concerns. As I mentioned, hot, dry, and windy. If we're taking out the wind component, that's one thing, and we're not factoring that in. But if we keep trending warmer and drier, that could be a problem. And that's where the focus will be for kind of future research, is kind of determining how those impacts will be related to climate change, and whether or not that warmer and drier will translate into more fires. Well, it's yet to be seen. But from a wind standpoint, there's no correlation that kind of shows that we're going to have more frequent Diablo events. And I think there's similar
Hmm.
research in Southern California when it comes to the Santa Anas as well, that there's not a lot of strong signal when it comes to the wind component. It's more the other factors that play into the weather concerns for hot and
Yeah.
dry or lack of
So
precipitation.
so we're definitely warming. That's undisputed.
Yep.
In the atmosphere, we're getting warmer. Um, we're having longer drought events that dry out the vegetation. That we're having episodes of very low humidity, right?
Yep.
That is a real trend too, isn't it?
Yeah, so that's another piece of research. Another famous climate scientist that does a lot with meteorology, but also has an interest in fire weather stuff. His name is Daniel Swain, and
Hmm.
he's written a few papers. And one of the things that one of his papers heavily looked at was not so much the moisture during the day, it's the moisture at night. How much moisture are we actually receiving at night? And when I'm referring to moisture, when we talk about it in a fire weather context, we're looking at like relative humidity, or how much moisture is in the atmosphere that will allow the plants to stay moist or dry out. And unfortunately, based off of some of the research that they conducted, there was a trend that show that we're getting drier at night. So that's the old saying used to be, firefighters won fire at night. Well, now it's getting a little bit more complicated. So if the trend is showing in the future that we're going to be warmer and drier at night, maybe we're not going to win as many fires at night. And I've seen that over the course of my short 20-year career, that crews fighting fire at night, they do make some headway, but it is getting to be a little more challenging because that reprieve or the break that the firefighters look for at nighttime isn't there as much anymore. And that's just anecdotally off of what I've seen. Now we have something called 2-day burn cycles, 2-period burn cycles in one day. So instead of just having peak fire during peak heating of the day when the sun's up, the sun sets and you would expect the humidity and temperatures to, be favorable and help kind of suppress the fire at night. That's not
Yeah.
happening as much. And we get that in the Bay Area. Pretty impressive at times. It's what we refer to in the business is called thermal belts. And that's basically saying warmer and drier conditions over the hills. One that comes to mind that's really notable was during the glass fire, which was also up in the Bay Area. That was in 2020. During the nighttime on that fire, temperatures were well into the 90s with humidities in the teens, and that should be when it's cooler and higher humidity. But we had Diablo winds, and thermal belts were really active. So it's becoming a challenge to fight fire at night as conditions kind of get warmer and drier over time.
Yeah, yeah, and not to get too far into the weeds here, meteorologically speaking, but it's a real concern, I would think, in the Bay Area and in the South Bay Area, for example, where we have in the Santa Clara Valley, for example, these inversions, right? These inversions that lead to spare the air days, where you can just see that that the air pollution is being held down in the Santa Clara Valley. And if there's a fire on top of that, and let's say a fire starts in an urban area, what are the implications for firefighting, at night when it's the most confusing, when it's the most difficult, I would think, to manage your resources and evacuate people, when you've got an inversion over the city as well and it's burning.
Yeah, that's definitely problematic because that inversion kind of acts like a lid. So if you do have a fire below it and you're putting smoke up into it, it's going to create visibility issues. You're not going to be able to see as well. That being said, if the fire's above the inversion, then it's going to be warmer and drier and it's going to have more ventilation. So it could actually burn a little bit more active. I will say one thing that has changed in the wildland firefighting business, so to speak, over the last few years is we're seeing an increase in aviation assets at night. They're using night vision goggles and other technology to allow helicopters and other aircraft to fly at night and kind of take advantage of what should be those quieter conditions to help suppress fire. And that's definitely a change. The last few years to see nighttime flying aviation assets is definitely helping the cause.
Yeah, that's great. Yeah, we welcome that. to, we're used to them during the day, but it's great to know that the technology is advancing so that they can help us when conditions are least favorable for people to make adjustments in their behavior, and the evacuation orders can come when they need to come, not just during the day. So yeah, that's great to hear. Well, Matthew, thank you so much for sharing all of this with us. I think we're right about at the limit we usually do time wise, but you've been just a wealth of information, and I'm glad we could talk about a couple of specific fires and even future scenarios, about this. Maybe we can pick it up later, and talk about a couple other aspects of it because I think we've just scratched the surface of fire weather, and the advances are coming fast and furious on your end, right?
They are. Yeah, we're always learning new stuff and new technology, higher resolution satellites, better weather models, uh, better research as far as the findings kind of giving us info. Yeah, we have a bright future. There's a lot of really good information coming to kind of battle these fires.
That makes us all feel much better that science can and technology can help us survive what is a just a naturally occurring fire environment we live in. Well, if we want to live here, we have to find a way to adapt to it, right?
Correct. Yep.
Right. Well, Matthew, Mehle, thank you so much for your time. And I hope that you don't have too many incidents to respond to this winter. Um, but we're coming up to the first anniversary of the Los Angeles fires in 2025, and so the fire season in Southern California. And how far down could you go? Do you have to work in on the Central Coast all the way down to say San Luis Obispo or places like that?
So we stop at the Monterey County line. That's where
Yeah,
my office covers, and then just to our south is the Los Angeles office. But we collaborate and coordinate because fire doesn't know geopolitical boundaries, and neither does the weather.
that's for sure. So, well, I hope you have a calm winter. We all
That's the
do.
hope.
Yes. Matthew, thanks, and I know our listeners are going to get a ton out of this one, and I may be calling on you again if you don't mind.
No, my pleasure.
Okay, thanks, Matthew. Have a great
Thank you.
day. Bye.